Let's discuss question number 36 from test 5. This is from strength of materials. Lot of questions this time from strength of materials. A solid shaft ABCD turns freely in a bearing and loaded at B and C by torques T1 and T2 is connected to the gearbox at A. So you have the gearbox at A and you have the shaft. Okay, at B you are applying torque, which is T1 2500 Newton meter. At C you are applying again the torques that are coming in the same direction as 1500 Newton meter. And at D it is free to rotate in a bearing. So this is and D, this is C, this is B, this is A, which is the gearbox. Okay, so now what is asked is find the angle of twist of the free end relative to A, because A is fixed, so we consider this as a reference, and the other stuff is given. Modulus of rigidity G is 0.8 into 10 power 5 MPa. The diameter of the shaft is 80 mm. Okay, so if I have a single shaft and a torque T is at 10, the angle of twist is T by J tau by R G theta by L. So if I use the first and the third equation, because I'm not interested in stress, so theta will be TL by GJ. This is for a section with the same torque. So what we will do is angle of twist of D relative to A is angle of twist of D relative to C, because CD is continuous with the same load, and then C relative to B, and then B. So we will divide this in section. Now D relative to C, you don't have any. If I take a section and balance the right hand side, I don't have any torque on this, so no torque, 0 is the angle of twist. Between B and C, so if I take a section and balance the right hand side, so I have only torque at C, that is T2. So at B the resistant torque has to be T2 only. So theta CB will be T2 length of BC by GJ. So T2 is 1500, length of BC is 0.9, G is 0.8 into, so 0.9 meters you can convert into mm, 0.9 into 10 power 3, and or either way, if you are convenient in meters, so let it be in meters, 10 power 9, 0.8 into 10 power 5 MPa, that is 10 power 6. So everything I am converting into meters. J is pi by 32, T power 4, diameter is 80, so 0.08 power 4. So this value, if you calculate, it comes out, the theta CP will come out. Okay, so we will do all the calculations later. So this is what is theta CB. Now for theta BA, let's take a section here and balance the torques on the right side. So the torque at this section is T1 plus T2, because on the right side you have both the torques acting in the same direction. So theta BA will be theta T1 plus T2 into length of AB, which is 0.6 by your GJ. G and J are same, 0.8 into, so let's substitute T1 25 T2, so this is 4000 Newton meter, 0.6 is the length, G is G is 0.8 into 10 power 5 into 10 power 6, converting in meters. J is pi by 32.08, because it's 80 mm whole power 4, pi by 32 power. So if I add this value and this value together, because that is what is mattered, right? So theta dA would be this is 0 plus, if I combine this plus this, okay, and I calculate, I get an answer which is 0.011656. So now this is in radians, you have to convert in degrees, so 180 by pi, so this will give close to 0.67 degrees. So the answer, the angle of twist of D relative to A is 0.67, answer is B. So this is a straightforward problem. Angle of twist at any section relative to the other can, if you have a continuous shafts, it's just TL by GJ, but then if you have stepped shaft like this, I mean not the step but loads at different loads at the different points, it's better to say break into each segments of continuous shaft with the continuous load and then apply this the way we have done. Thank you.